morning and welcome back again to Go Forth and a little bit of learning with me, Mr. Forth. Today we're going to be carrying on with the idea of mastery of measurements. This time, however, we're going to be thinking about area. Now, before we get into the lesson today, just a couple of changes because, like we said, this is all brave new world for us. A couple of changes we want to make. Firstly, comments. What we found was that loads of you were really engaging, which is brilliant. However, I'm one of those teachers that just loves the sound of his own voice. And if I know that people are chatting away, even if it's on the comment section, rather than listening and enjoying all of this coming out of my mouth, well, that doesn't sit well with me. So if you can hold fire on some of the random chatting so you're focused on the lesson, that would be awesome. If you are finding the other comments from people a little bit distracting even, you can swipe away on the phone, swipe right, or if you're on a laptop or a computer, you can just make the screen full screen, the picture, and that'll help remove any of those distractions. Okay, so this lesson today. Again, another one on mastery. And as I said before, mastery is all about not trying to learn anything brand new, but taking that maths learning that you already have and making use of it in loads of different situations. What that helps do is, when you're talking to your parents and they're asking you, what have you done today? And for the life of you, you cannot remember what that was. Well, that's where mastery comes in. It helps embed that learning that you've done into your long-term memory so that it really sticks in there. And it means that whenever anyone asks you questions about it, you can do it. Now, there are particular bits of maths that we try and do that really a lot with, just because we use it so often. One of those is times tables. Now, that Joe Wicks, he's been doing some of our PE stuff. And at the beginning of his, he does warm-ups. Well, we're going to do something similar just to get you primed and ready. We're going to do a warm-up, but for your maths brain. Okay, so we are going to get onto area shortly, but first we're going to just be thinking about our times tables. And because I'm a little bit of a meanie, we're going to start with the 6 times table. Yeah? Okay. This is a little bit of an activity that I like to do with my classes. Works great in pairs. However, if you don't have someone there with you, we can do it along together. What I tend to do is write the numbers 1 to 12 in a random order. So I've got them here on my sheet. You can see I've got my little cribs underneath as well in orange. They're the answers. So what I tend to do is have one partner shout out a number. So in this case, the first number is 7. And their partner would have to respond with the answer to that times table. So 7 times 6, which is, Jamie, do you know? No, 42. Okay, so what we're going to do is have a little go at trying that. Now, if you don't have someone to do that with in your room with you, that's okay. We can do it. I'll shout the numbers out, and what I'll need from you is to shout back the answers really loud in the hope that I can hear. We'll give that a go, should we? Right. Set. So 6 times table. I'm going to shout a number. You need to multiply it by 6. Tell me the answer. Okay. 7. Good. Okay. 4. Good. Easy one now. 1. Yep. Easy. 2. Yep. 10. 10 times 6. Yeah, obviously. 9. Try it again, even louder. 9 times 6. Good work. Okay, 6. Classic. 6 squared. 6 times 6. What is the answer? 8 times 6. 3 times 6. 5 times 6. 12 times 6. And finally, 11 times 6. Wow. Okay. Good work. that is a really good and quick and easy game to do, to kind of practice your 6 times tables or any times table. Works really well with other people though. You might have just sounded a little bit weird shouting random numbers out. Don't worry, this is something I've learned I've had to do at work quite often. It's just to whoever is around and might not understand what you're doing, just shout nice and clearly, don't worry, I'm not mad, I'm just doing maths. They'll understand. Okay, so hopefully we're all warmed up. If you're just joining in us again, we've been warming ourselves up with a bit of times table action, ready to do some work on area. That's our mastery of measurement today. Now, what we're going to do is think about, first of all, how does learning our times tables link back in with area? I mean, it's actually really straightforward, because area, when you're trying to work out the space of a 2D shape, that's what we're looking at really with area, there's this really simple formula, which is length times width. L times W, if you will. And yeah, as you can see, that is just simply one multiplication that you're expected to do. So if I had a room that was 3 meters by 2 meters, if you know your 3 times table, you are sorted. 3 times 2, 6. So that is really easy. And that's where the mastery bit comes in. If you've got your times table knowledge, you can do area knowledge really simply. However, it's a little bit more than just a number. I was a real stickler in the classroom for this. My class would get a wrong answer if they gave me the right number, but forgot this key bit of information: the unit of measurement. Because, yeah, we're talking about a measure, a length of space. So you need to make sure that you're including that. Because that is how we make sure that we've got a space. But in the real world, sadly, area isn't as straightforward as all that. It would be lovely if we all had just great square and rectangular spaces that we needed to measure. Then we could do it really simply. However, that's not quite the case. Take this room that I'm in at the moment, for instance. It might look like a fairly normal room, except it's got a huge map on the wall. But this bit here is a wonky bit. It sticks out, it juts into the room. It makes it less than a rectangle and gives it all kind of squidgy lines. That makes working out area a little bit more complicated. So what I've always found is that mathematicians are incredibly lazy. They will always look for the quick and easy solution to any situation. And when it comes to wonky rooms and trying to measure the area of them, mathematicians have it sussed. They go for something called compound area. Right, compound. You might have heard that used in all sorts of different places. I've heard it used in science, for instance, but we can use it here in maths because it's all about mixing bits together. Now, I'm not sure. Hopefully, you will have seen in the link to today's live lesson, there was also a link to some supporting resources. There was an activity sheet from Twinkl all about compound area. So if you've had a look at that, that's great. In fact, I'm going to just pop a little poll on and see how many of you have actually seen that. See if I've had more luck with the poll today compared to yesterday. I'll leave that running and see how that goes. Okay. Compound area is really simple. Again, we take that idea of the length times the width that works for a square or rectangle, but instead we break a room into smaller squares and rectangles. Let me see if I can get my little piece of paper here. I can draw you an example. Do excuse the messiness of this. You will tell me off instantly for not using a pencil and a ruler, which is obviously the right and appropriate thing to do. But if you have a wonky room like this, you can split it into a bigger rectangle and a smaller one. Then, if you have the measurements for those, you can really simply work out the area of each, combine the two, Bob's your uncle. You have got your area for that shape. That isn't exactly a square or a rectangle. Okay. So, just to reiterate, this is mastery of measurement. We are working out area. At the moment, we have already used our times table knowledge to help us really simply get our heads around the idea of working out area, which is length times width. We have then started thinking about compound area, which is when you have a space that isn't exactly a rectangle or square, how you can work out the area of each of those aspects, combine them to find out the total area. Now, I had a little bit of a go at this earlier and thought I was being really clever because I had the great big room, part of my room, that I thought I can measure really easily with my tape measure. First things first, it isn't as easy as you would think to measure an entire room on your own. So if you do have someone else that can help you do that, that is brilliant. I found that it is a very long way and the tape measure doesn't like staying up that long. Now, I then was trying to be a little bit clever because my wonky bit over there is only little. I thought, haha, I can be more accurate and use instead my ruler for measuring that bit. It did leave me with a little bit of a problem though. So I had the room measured in a larger unit of measure. Can you guess which one it is? Yeah, I tried to use meters. And because this distance here, oh, see what I mean? It's just not wanting to stay up. If I show you, that is a meter. Great big amount. And you can see that I've got 1, 2, 3 and a bit of those across. Now, that little bit didn't need a whole tape measure to measure it. I can just do it with my ruler. In fact, it's even shorter than my ruler. It's about 23, 24 centimetres. I was doing that roughly there. It is 24 centimetres. Now, I've got my huge length of wall as 3 meters, 3.66 meters, my calculations tell me. And the small part that I'm going to try and work out the area of, that I can then take away from the total size of my room to work out that compound area in centimeters. Nah, it didn't work. I ended up with some weird and wonderful calculations because I was trying to mix measurements. So a real key learning point for you is when you're trying to measure the area, you want to stick to using the same unit of measure. If you're going to do any converting, you want to do it before you start doing any of your calculations, that length times width bit. Because as soon as you've done that, you've got a different unit of measure. That's the squared, meters squared, centimeters squared, and that is a very different proposition to trying to just add normal centimeters and meters. Okay, so as a recap, let's see if we can go through. We have used times table knowledge. That is a given. We need to be really 100% accurate that we are doing our times tables well to work out area, so that we can confidently say the area of an area, a square or a rectangle. We've then been able to separate out other squares and rectangles in a funny wonky shaped room to work out the compound area, making sure that we use the same unit of measure. We talked a little bit about conversion yesterday, and that's if you do need to try, if you've measured one area in meters and one in centimeters, making sure that you convert to the same amount. Luckily, meters, centimeters, they're both metric, both based on that base 10 idea that we again talked about yesterday. So you can simply multiply or times by 100, depending on which way you want to go. If you're wanting to turn centimeters into meters, we divide down. If you're wanting to turn meters into centimeters, we multiply up. Okay, I think we've got a good grounding of knowledge so far for us to be thinking about what we're going to do next, which is thinking about how we can draw that information down. Because if you've seen that activity sheet, you will have noticed that those rooms, those spaces that were on that sheet are not representative. They are not 3 meters by 2 meters. That would be ridiculous trying to squeeze that onto a piece of paper. So we use scale again just to draw it all down. Okay, so a real key thing with scale is making sure that the scale that you're using is clear enough for you to see. So when you're trying to draw on a piece of paper, it's not really diddy or too huge that it doesn't even fit on properly. And that you are consistent. It is no good turning one into using one scale for one side, the length for instance, and another scale for the width. Got to use the same for both. So this is where I get my little bit of a Blue Peter moment. I had a go at drawing this room that I'm in at the moment. I did my measurements in meters. I stuck with meters because I felt that I was more confident with those. And then I tried to work out a scale. Now, my bit of paper here is about 30 centimeters, I know that. And as you can see, I've been able to plot out my room. Now, I've decided to go for, get it on the right side there, you can see, gone for 1 meter. For every 1 meter, I'm going to use 5 centimeters. So because this room is around 3 meters long, 3.42 to be precise, how many centimeters would I have used roughly there? Well, if every 1 meter is being represented by 5 centimeters, that means that 2 meters would be 10 centimeters, 3 meters would be 15 centimeters, so 3.42, just a little bit over that one there. I think I went for about 17 centimeters. This is where you probably go to me, Mr. Foff, you're not being accurate enough. I know, you can do a better job than me at this. But I was happy with that scale because it gives me the ability to plot out the room on my piece of paper, big enough that I can sit and put some information in there, but small enough that it doesn't take up the entire space or fall off the end. I've tried to do that before where I started on a scale and it looked like it was going to be really good. Ran out of space on my piece of paper. Okay. So, why am I telling you all this? What are we going to do today in order to take advantage of all of this area knowledge? Right. I've got 3 challenges for you. You can try and do all 3 of them, 1 of them, 2 of them. It is your choice, okay? It is what you feel comfortable with. So the first one is really dead simple. What you need to do is print off that sheet that we've linked to as part of the timetable, and then you can have a go at filling that in and doing that yourself. Sorry, I got a little bit distracted there. Can you just make sure that the comments that you are leaving on this thing are all about maths, if that's at all possible, and think, actually, do you need to be writing anything at the moment? Is this going to help you take in this learning? If not, don't worry. We'll have an opportunity to share what we've been learning after this, okay? Thank you. Right. So, challenge 1. Use that activity sheet that we've shared with you already. Have a go at completing that. See how brilliantly easy you find it now you are applying your multiplication knowledge to your area knowledge to your compound area knowledge. Number 2, a little bit of a trickier challenge for you. You can have a go at what I was doing with a tape measure and having a go at measuring a space in your house. I would recommend your bedroom. That would be a perfect place to begin. And here you go as a real challenge. Work out what you could fill the floor space with in your room. So if you can work out the area of your bedroom, then have a go at working out the area of something smaller, for instance, and working out how many of those said items can fit into your room. Let me give you an example. I have 1 smelly sock. I have measured said smelly sock using my tape measure with my ruler. Yes. 30 centimeters by 10 centimeters. Now I could just work out the length and width like that, but I won't because I have measured this room in meters. So I need to convert 30 centimeters is 0.3 meters. 10 centimeters is 0.1. When you multiply them together, because they're decimals, it's weird, it gets smaller. You get an answer of 0.03 meters. Don't worry, I used a calculator for this bit. I would fully expect you to do so too. I then took the area of my room, which turned out to be 8.78 meters, and divided that by 0.03 meters. Can you work out how many smelly socks I can fit in this room? I'll give you a chance. No, not a million. 7? The answer, okay, is 290 smelly socks. Imagine that. Floor covered in them. Wouldn't have to do any hoovering for days if that was the case. So that's challenge 2. Work out the area of your bedroom and then work out the weirdest thing that you could fill the floor with and how many it would take. One final challenge for you. Challenge 3. And this, to be fair, is my favourite of the challenges. You can have a go at using scale alongside your area knowledge to have a go at drawing, like I have here, the space that you're in at the moment, or it could be your bedroom, somewhere in your house. Now, you could just leave it like I have, but that's a bit dull. So, how about using that floor plan to design the greatest and best home learning environment ever? Imagine what you could fill it with. Desk full of computers, bean bags for a little bit of a chill out area, huge whiteboards for doing really impressive maths calculations on. Who knows what your brain could come up with? It would be amazing. Let's see what you can put in there. So, that is my challenge for you today. If, however, we've gone through this stuff and your brain is going, whoa, Mr. Fourth, I still don't really understand area. Do not worry. That's the whole joy of mastery of maths. You can take it back and think about what is the bit that you're not really sure about and dig into that a little bit more. Find some resources to help you with that. Twinkl is brilliant for that. If you go to the homepage on Twinkl and then go to Key Stage 2 at the top, you can then click in. It gives you the option of all the different subjects. From there, you can go into maths, and then you can have a little think about what it is that you're not sure about and would like some help on. If it is the measurements bit, click on that option there. If it's the times tables, have a look at those times table resources. There's loads to help you with. What we'll do, we'll share a little link to show a little video just to show you how it's done as well after we've done this. Okay. I would love to see your efforts, be it the random things that you're filling your floor with, completed activity sheets, or best of all, the plans that you've come up with for your perfect learning environments. I'm going to leave you now to have a go at doing that, and I'm looking forward to seeing what you manage to create. Right. For now then, goodbye. Thank you very much for listening. Good luck with your maths and in particular your area.